Camera rolling. By the way, this is not an energy drink commercial. It's a science lesson at the end of a long week. Let's get started. Let's do this past paper question on electrochemistry. This question is specifically looking at galvanic cells. Let's get started. Question 8 says, learners want to identify an unknown metal X using a standard half cell, X converted into X2 plus. They set up an electrochemical cell under standard conditions using two half cells, as shown in the diagram below. So we can see there a galvanic cell. On one side, we've got an X half cell. The other side, we've got a hydrogen half cell. But because hydrogen is a gas, we have to use platinum as an electrode. Then they tell us the initial EMF of the cell is 1.2 volts. 8.1 says, state the standard conditions under which the cell functions. Now, I've seen a lot of learners make this mistake where they confuse standard conditions for standard temperature and pressure. So STP and standard conditions are two different things. So standard conditions, you need to note that your solutions must all have a concentration of 1 mole per decimeter cubed. So 1 mole per dm cubed. Right. Another condition is you have to have a temperature of 25 degrees Celsius or 298 Kelvin. Finally, the third one is 1 atmosphere of pressure, or 101.3 kilopascals. So 1 atmosphere of pressure. Perfect. 3 very easy marks for this first question. 8.2 then says, state one function of component Y. So when we look at our diagram, we can see component Y is this component over here. Right. First of all, what do we call that component? Type it in the chat quickly before I write it down on my piece of paper, or my iPad rather. Yes, correct. This is a salt bridge. Now, salt bridge will have 3 functions. You've been asked just to give one of those functions. You can have one of the following. Number 1, it either completes my circuit, right? Number 2, it maintains electrical neutrality. Or number 3, it keeps my electrolytes separate. Let's quickly put those 3 down, and any one of them you can put down as your correct answer. Fantastic. Notice how out of 4 marks that we've gotten, they're pretty easy. This is a 14-mark question. We're already sort of 30% into this question paper, right? And we haven't actually had to use our brains. The next part of the question then says, after the cell has operated for some time, it is found that the mass of electrode X has increased. Identify X by means of a suitable calculation, right? So when you look at the information that's been given to us, all we've got really is the fact that the EMF of the cell is 1.2 volts. So I'm going to use that as a starting point where I'm going to use my EMF calculation. So we know that our EMF is the same thing as our E cell, right? And E cell becomes the E naught value of our cathode minus the E naught value of our anode, right? Now, the cathode, we already discussed the fact that reduction happens in our X half cell. That's going to be the cathode. So that'll be then our E cell value there is going to be 1.20. We were given that. The cathode becomes the E naught value of X minus the E naught value of the anode, that's hydrogen. So if you go back and you look at your table of reduction potentials, right, you can see there clearly hydrogen will have a value of 0. So we can take that value of 0, plug it into our calculation there, and find our final answer. Then we can see here that the E naught value for X is 1,20 volts. To figure out what the metal is, let's go back to our table and find what gives us a value of 1.20, right? So here's 1.20, and we can see 1.20 gives us platinum, right? Super useful, super easy as well. Let's quickly go put that in our final answer. So here we've got there, and we can say therefore X is platinum. Done. Nothing too hectic. We've now got 9 marks out of 14, right? That's well over 50%, and we didn't have to work that hard. Guys, this stuff is really easy. You guys can do it. Okay, let's look at question 8.4. 8.4 says, write down the oxidation half reaction that takes place in the cell. When we look at our electrochemical cell, we can see there, like we've mentioned already, reduction happens on the left-hand side. That's the X half cell. oxidation happens on the right-hand side. That's the hydrogen half cell. So let's simply write down the oxidation half reaction for hydrogen, right? So there we pump in hydrogen gas. So we're going to have hydrogen gas coming in, and that hydrogen gas will then split up into H plus, but to balance it out, it's going to be two of them, and that's going to be an aqueous solution plus 2 electrons. Again, super easy, quite nothing very challenging at all. Now we're already at 11 marks out of 14, and we haven't actually had to use our brains. Okay, now for 8.5, we're told that the half cell X and X2 is now replaced with a gold half cell. The initial EMF of the cell is now 1.5 volts. As the cell operates, the gold electrode increases in mass, which means it's going to be the cathode, it'll be the reduction side. Then we're told to arrange the oxidizing agents X2 plus, Au3 plus, and H plus in order of increasing strength, and then fully explain our answers. So let's have a look at our table 4b again quickly. So let's find the values. So first of all, here we can see H plus, we've got that there. We've got PT2 plus. The one trick is with this question, you will notice that you will not see Au3 plus on this table. So it becomes difficult to do that. But we were given a piece of information, right? If you go back to the question, we were told the EMF of the cell. And because it's connected to a hydrogen half cell, basically this would be our E naught value. And one thing that you should know is when you have a greater E naught value, what that means is you have a much stronger oxidizing agent, right? In that case there. So when we arrange these there, we can first see H plus has got an E naught value of 0, because remember, when you look at the table, the left-hand side says increasing oxidizing ability going down, meaning your stronger oxidizing agents on the bottom left of the table. So when we look at H plus, it's going to have a value of 0, PT2 plus a value of 1.2, and Au3 plus should have a value of 1.5, but it isn't on our table. So it'll sit somewhere here, right? Where we should then have somewhere in that gap there, Au3 plus. So as we go down, they get stronger and stronger in oxidizing ability, or in terms of their strengths of relative oxidizing agents, or the relative strengths of the oxidizing agent. So H plus, PT2 plus, and then Au3 plus. Let's quickly put that answer down there. So we said final answer is going to be H plus, right? And then we've got PT2 plus, or we can just call it X2 plus. And then finally you've got Au3 plus. Fully explain your answer. In that case there, we can say the greater the E naught value, the stronger the oxidizing agent. And then we can even maybe put the values there so that they've got them. This is 0 volts here. This is, it was given to us as 1.2. And this is 0.5. 1.50 volts. And that's 14 marks. That's our question. Well done, guys. Please make sure to subscribe to our YouTube channel to watch more awesome content. Come back when we do the next question, which is going to be a question on the electrolytic cell. And make sure you are following us on TikTok and on Instagram. Go to the Learning Space website if you'd like to engage with myself or any of our other tutors, because we really want to help you guys make sure you do as best as you possibly can for these upcoming exams. See you guys next time. Cheers.